Hello everyone, James here from JTS Maths Tutoring. Today we are going to look at how to solve the limit of a function using a graph. Right, we've got the given graph right here, and these are the questions here. So the very first question is what is the value of this function at x is equal to -2? So it is actually indicated by the field in circle here at coordinates -2 and -3. That means that is the value of this function at x is equal to -2. The second question says, what is the limit of this function here as x is approaching -2 from the left? So you're moving from the left-hand side here. As we are going to approach -2, we make use of this red arrow. This is the piece of the function that we are looking at here. And we can see from the graph that the function tends to -1. So that will be our solution here. And the third question is that what is the limit of this very same function as x is approaching -2 from the right-hand side? So this is the piece that we are looking at as it is approaching -2 from the right side. We follow this orange arrow, and we can see again from the graph that the function tends to -1. And now the fourth question says, now what is the limit of this function g of x as x approaches -2? So here is the catch. For this function to exist, for this function to exist, it means the limit of this function is x is approaching -2 from the left-hand side, and the limit of this very same function is x is approaching -2 from the right-hand side. It must be equal, it must be the same for it to exist. So we can see from 2 and 3 above that from the left-hand side and from the right-hand side as x is approaching -2, the limits are the same, -1. So it means the limit of this function is x is approaching -2 is -1. Right, the fifth question, what is the limit of this function g of x as x is approaching 2 from the left? We are looking at this piece here. Remember, this is a piecewise function. And here we follow this dark red arrow. So we can see from the graph that as x is approaching 2 from the left, the graph or the function tends to -5. -5. Now, question 6. Question 6, what is the limit of g of x as x is approaching 2 from the right side? This is the piece that we are looking at here. So we follow this blue arrow here, and we can see from the graph that as x is approaching 2 from the right side, the function tends to 1. So that will be our answer here. Now, question 7 is now asking us, what is the limit of g of x as x is approaching 2? So remember, for the limit to exist here, the limit as x is approaching 2 from the left-hand side and from the right-hand side, it must be equal. But we can see from 5 and 6 here that they are not equal. So we conclude here the limit does not exist. The reason why it does not exist is because from the left side and from the right side of 2, they are not the same. Doesn't exist or does not exist. All right. Cool. The limit doesn't exist there. Number 8, what is the value of the function of g of x at x is close to 3? So you can see here what I did. I actually drew these solid black lines. So you can see the reason why they are actually said approximately. I did not put an equal sign there because I'm not so sure exactly what is the exact. So I can say here the value of g of x at x is equals to 3 is approximately maybe 1.7, 1.8, or 1.9. So let me just say 1.8 here. Right. So what will be the limit of this g of x as x is approaching 3 from the left? I follow this purple line here. And you can see that it is also approximately what? 1.8. Right? What about when it is approaching 3 from the right-hand side? So I use this brown arrow here. It is also approximately 1.8. So what is the limit of g of x as x is approaching 3? So since 9 and 10 here, they are equal, it follows the fact that the limit of g of x as x is approaching 3 is also approximately 1.8. Right. Then question B, identify the discontinuities in the function g of x graphed above. So we can see that here at x is equals to -2, there is a removable discontinuity. And at x is equals to 2, there is a jump discontinuity. Right? So there is a removable discontinuity at x is equals to -2. And a jump discontinuity. X is equals to 2. There we are. We are done. If there are any questions, you can post some questions on our Instagram page as well as on our Facebook page. We will deal with more examples. But thank you so much for tuning in. Allow me to do what my mama taught me. A good dancer knows when to leave the dance floor. Adios, amigo.